trigonometric ratios beyond 90 degrees. In 1831, Michael Faraday discovered that an electric current was generated by rotating a coil of wire in a magnetic field. The electric current displayed a voltage which varied between positive and negative values as the coil rotated through 360 degrees. The resultant voltage represented a sine wave. To find the magnitude of voltage at an angle of rotation greater than 90 degrees, say 120 degrees, 200 degrees, or 300 degrees, we need to know the trigonometric values of angles greater than 90 degrees, represented in the 4 quadrants of a rectangular coordinate plane. Understanding quadrants. In a rectangular coordinate plane, the horizontal line is called x-axis and the vertical line is called y-axis. The x-axis and the y-axis divide the plane into 4 parts: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We must note that the x-axis and the y-axis do not belong to any of the 4 quadrants. Measurements of angles at various positions in a rectangular coordinate plane in one rotation. Let us assume that a unit radius is rotated from the positive x-axis and the angles 30 degrees, 45 degrees, 60 degrees traced by the unit radius are in the first quadrant. Angles of measures 120 degrees, 135 degrees, 150 degrees are in the second quadrant. Angles that measure 210 degrees, 225 degrees, 240 degrees lie in the third quadrant. And angles that measure 300 degrees, 315 degrees, 330 degrees are in the fourth quadrant. So, in the first quadrant, the angle theta is greater than 0 and less than 90 degrees. In the second quadrant, theta takes measures between 90 degrees and 180 degrees. In the third quadrant, theta varies from 180 degrees to 270 degrees. In the fourth quadrant, it varies from 270 degrees to 360 degrees. It must be noted that angles 0 degrees, 90 degrees, 180 degrees, and 270 degrees do not belong to any quadrant. Let us assume that a point A moves in anti-clockwise direction around the circumference of a unit radius circle, and the angle theta changes from 0 to 360 degrees. Consider a right-angled triangle formed by the vertical line AD, OA, and the x-axis. If OD is equal to x and AD is equal to y, then the coordinates of point A are x, y. In the triangle ODA, cos theta is x by 1, and sin theta is y by 1. Therefore, x is equal to cos theta and y is equal to sin theta. Therefore, we can re-represent the coordinates or ordered pair of point A as cos theta, sin theta. Let us understand this better. In the first quadrant, x is greater than 0 and y is greater than 0. Therefore, sin theta is equal to y by r, which is greater than 0. Cos theta is equal to x by r, greater than 0. Tan theta is equal to y by x, greater than 0. Cosecant theta is equal to r by y, greater than 0. Secant theta is equal to r by x, greater than 0. And cot theta is equal to x by y, which is also greater than 0. So as you can see, all trigonometric functions in the first quadrant are positive. In the second quadrant, x is less than 0 and y is greater than 0. That is, x is negative and y is positive. Sin theta is equal to y by r, which is greater than 0. Cos theta is equal to x by r, which is less than 0. Tan theta is equal to y by x, which is also less than 0. Cosecant theta is equal to r by y, which is greater than 0. Secant theta is equal to r by x, which is less than 0. And cot theta is equal to x by y, which is also less than 0. So in the second quadrant, trigonometric functions such as sine and cosecant are positive, while the others are negative. In the third quadrant, x is less than 0, and y is also less than 0. Sin theta is equal to y by r, less than 0. Cos theta is equal to x by r less than 0. Tan theta is equal to y by x greater than 0. Cosecant theta is equal to r by y less than 0. Secant theta is equal to r by x less than 0. Cot theta is equal to x by y greater than 0. So, all trigonometric functions except tangent and cotangent are negative in the third quadrant. In the fourth quadrant, x is greater than 0, y is less than 0. Sin theta is equal to y by r less than 0. Cos theta is equal to x by r greater than 0. Tan theta is equal to y by x less than 0. Cosecant is equal to r by y less than 0. Secant theta is equal to r by x greater than 0. Cot theta is equal to x by y less than 0. So all trigonometric functions in the fourth quadrant are negative except cosine and secant. If a ray rotates through an angle greater than 360 degrees, it will stop in the first quadrant, and the angle it rotates through will be in the form of 360 plus theta. For example, sine 360 plus theta is equal to sine theta. If the rotating ray has made more than one rotation, say n number of rotations plus theta degrees, where theta is acute, it will stop in the first quadrant and will be in the form of n times 360 degrees plus theta. The same rule is applicable to all the angles in the form of sine, n times 360 plus theta. Let us summarize the results. In the first quadrant, all the trigonometric ratios are positive. In the second quadrant, sine and cosecant are positive, rest of the ratios are negative. In the third quadrant, tan and cot are positive, rest of the ratios are negative. In the fourth quadrant, cos and secant are positive, rest of the ratios are negative. If we were to make a mnemonic for positive ratios in the four quadrants as ASTC, as in A in the first quadrant, S in the second quadrant, T in the third quadrant, and C in the fourth quadrant, we could remember ASTC with a mnemonic after school to college. Let us see. In the first quadrant, the possible angles are theta and 90 degrees minus theta. In the second quadrant, the possible angles are 90 degrees plus theta and 180 degrees minus theta. In the third quadrant, the possible angles are 180 degrees plus theta and 270 degrees minus theta. In the fourth quadrant, the possible angles are 270 degrees plus theta and 360 degrees minus theta. Now let us find trigonometric ratios in various quadrants. The angles 180 degrees minus theta, 180 degrees plus theta, 360 degrees minus theta, 0 degrees minus theta are in the form of an even multiples of 90 degrees plus or minus theta. The angle 90 degrees minus theta, 90 degrees plus theta, 270 degrees minus theta, 270 degrees plus theta are in the form of odd multiples of 90 degrees plus or minus theta. For even multiples of 90 degrees, there is no change in trigonometric function, so sine remains as sine, cos remains as cos, tan remains as tan, cot remains as cot, secant remains as secant, cosecant remains as secant. For odd multiples of 90 degrees, there is a change in trigonometric function. Sine changes to cos changes to sine, tan changes to cot changes to tan, secant changes to cosecant changes to secant. Example. Let us look at an example. Cos 180 degrees plus theta. Here, 180 degrees plus theta belongs to third quadrant. As you know, the trigonometric ratio of cos is negative in the third quadrant. Also, minus 180 degrees plus theta is an even multiple of 90 degrees plus theta. So, there is no change in the trigonometric function. Cos remains cos. Therefore, cos 180 degrees plus theta is equal to minus cos theta.